Hello. Now we're going to do some examples of the fundamental theorem of calculus. Before we do that, here are some guidelines. It just reminds you that if you're going to take the definite integral, you write the antiderivative, then lower limit, upper limit, and then just do plug in the upper limit and then minus what you get when you plug in the lower limit. So they gave you an example here. And then there's another thing about sometimes people wonder what happens to the plus c, because when we did indefinite integrals, we always had a plus c. You still do get a plus c. But what happens, so that's the antiderivative of f. What happens when you subtract these two things, you're really basically getting a c minus that same c, which is 0. So you don't have to worry about it. So here's some examples. And I also want to go through some checks with you. The integral of the square root of x from 0 to 4. First thing we do is remember that this is x to the 1/2. Integrate it, which means you add 1 to the exponent, which is 3/2, and then multiply by 2/3, and then evaluate it from 0 to 4. Now the 2/3 is a constant. So if you keep it out of the brackets, that's fine. Just multiply it through at the end. If you leave it inside the brackets, then it's going to come up with both terms. For that reason, I like to leave it outside the brackets. Remember, you can only do that for a constant if it's a number. So it's 2/3 times, now you plug in 4 to the 3/2, and then minus you plug in 0. 4 to the 3/2 is the square root of 4 first, which is 2, and then cubed, which is 8. And obviously 0 to the 3/2 is 0. So we have 2 times 8/3, which is 16/3. That's the definite integral. Now, is that the area under the graph of the square root of x from 0 to 4? Only if that is non-negative. Only if that graph is positive. So I'm using Wolfram Alpha to check. You may or may not have a graphing calculator, so it doesn't really matter. Using Wolfram Alpha, you just type in the integral of the square root of x from 0 to 4. You'll know what you mean. And then it's going to give you, I'll put it over here because it's going to give you this answer, 16/3, which is what we got. Approximation. You can see a visual representation, which is pretty big. That shows us that this graph is non-negative, so it did calculate the area. That is the area under the graph of the square root of x. Next example is the definite integral from -3 to 3 of x cubed. So this is ready to go. We don't have to rewrite it. The antiderivative of x to the third is x to the 4th times 1/4. And then we're going to evaluate that from -3 to +3. So we have 1/4 times 3 to the 4th minus -3 to the 4th. 3 to the 4th is just 3 times 3 times 3 times 3, or is just 9 times 9. So 3 to the 4th is 81. Minus -3 to the 4th is also 81. It's raised to an even exponent, so that negative cancels out. So we have 81 minus 81, which is 0. So we have 1/4 times 0, which is 0. So I can tell you right now, it didn't calculate the area underneath that graph because that's not going to be 0. So something's going on here. If you look on the graphing calculator, type it in, And then second calc 7, that's the definite integral, and type in -3, enter, and 3, enter. The graph, you know what it looks like. And it calculated this area from -3 to 3, and this area from +3 to 3. This would be negative because the graph is below the x-axis. This is positive. They're the exact same area because of the symmetry, so they cancel each other out to be 0. So that makes a heck of a lot of sense. Last algebraic example is this. This is a little bit more complicated because you have to remember that you can't integrate this. Like, we don't have a product rule of integration, and this is a product of two functions, nor will we really ever have a product rule of integration. We have to make this as a sum or difference. So you're going to take this x to the 1/3 because it's the cube root of x and distribute first. So this will be 2x to the 1/3 minus x to the 1 times x to the 1/3, and 1 plus 1/3 is 4/3. That's a 4. Then you integrate. So add 1 to the exponent, 4/3. Multiply by 3/4. That will be 6/4, or just 3/2. Minus. Add 1 to the exponent, 7/3, times 3/7. And then we're going to evaluate that from 0 to 1. So that doesn't look like fun, but this is going to be pretty easy once you see what happens. We'll have 3/2 times 1 to the 4/3, which is 1, minus 3/7 times 1 to the 7/3, which is 1, and then minus 0 minus 0. So I'm just going to get a common denominator of 14. So multiply this by 7/7, and this by 2/2. 21 minus 6 is 15/14. So that answer is 15/14, or 1 1/14. That equals 1.07-ish. So quick check on the calculator. Type in the function to y equals, and then second calc 7 for integral, and then type in 0 to 1, and you get this 1.071. So that checks. We did it right. That's it. Then make sure you watch the next video because I'm going to do a couple trig problems for you, and then I'll let you practice.